Hello, if you're joining, welcome to this free prep hour, Manhattan Prep free prep hour. My name is Logan. I'm going to tell you a little bit about me in a minute and a little bit what we're going to do tonight in a minute. And I'm just going to let everybody filter in for now. All right, hey everybody. My name is Logan. This is a Manhattan Prep GRE free prep hour. What we're going to be doing tonight is, as it says up here, we're going to be talking about the coordinate plane, which is a sort of small topic within geometry on the test. But it's one that you've probably done in the past, and a little bit of refresher can probably bring back a lot of what you used to know, which can be very helpful. Let me tell y'all a little bit about me. I'm Logan. I live in Queens, New York. I've been teaching the GRE since 2018 here at Manhattan Prep, but actually this is my first free prep hour, and I'm very excited about that. I've always really liked the free prep hours. I've watched tons of the ones that we have up on YouTube, and I'm excited to be part of them now for the first time. If this is your first free prep hour, let me tell you a little bit about them. We'll be here for an hour. We're going to cover this topic that I chose for tonight. I looked through all the prep hours we've got up on our YouTube to try to find something that we haven't talked about much before, because we keep a library of these on our YouTube channel that y'all can watch anytime, and go check them out. They're fun. You can talk to me through the chat. You can also talk to everybody through the chat. I'm going to ask y'all to comment in the chat when we get to some questions. And if you want to send your answer to everyone, which is what I'm going to ask you to do most of the time, you can just type to everyone, and then you should have a button there that says to hosts and panelists. That's if you want to send something just to me. And a quick fact about me, figured I should toss something in. I just adopted a dog. How cool is that? Just a couple weeks ago, got a new puppy in the house. Hopefully you don't hear him crying in the background. But let's talk about the topic for tonight, graphs on the GRE. And there's a couple types of graphs. So specifically, I mean these coordinate plane graphs. Coordinate plane graphs, what this is it's on your XY plane. You probably know it. You probably learned it back in middle school, high school, when you were first learning different types of geometry, but it's not something we use every day. So a few notes on this topic. This is not one of the biggest topics on the test. Not at all. It's not even one of the biggest geometry topics. That would kind of be circles and triangles and some of the basic lines, angles stuff. But this is a topic where you can sort of shake off the rust with a bit of practice. The basics of this, maybe not for everyone, depending on what math classes you took back in the day, but probably things that you did learn at one point and actually did a lot of growing up. So in that way, I think it can be valuable to learn and practice this, because it might be low-hanging fruit in that way, where these skills are back there in your brain. We just got to kind of find where they are in the library. So we're going to cover the basics tonight, and then we're going to cover a couple advanced things. So first, probably 30 minutes or so, we'll cover these basics. That'll kind of just be me going over a few of the main things and then asking you a few questions based on them. We're going to just take a look at what is the XY plane. We're going to talk about slope. We're going to talk about distance between points. If you've got one of these graphs, how do you tell how far apart two different points are? And then we're going to talk about y equals mx plus b. Specifically, this is the basics of linear graphs. Because I'd say if you're just getting back into this as a topic, that's where you want to start, linear graphs. Then we're going to do a few advanced things at the end of the night just to see how they mix it up on the GRE. And really, in my mind, there's three ways that they sometimes mix it up. One is inequalities. So this wouldn't be y equals, but y is greater than or less than. Then we get parabolas. That's that U shape that we sometimes see instead of a straight line. And then we have shapes on the graph. So sometimes they will, put a circle on an XY plane, or a triangle, or a parallelogram, or something like that. So we're going to take a look at that as well. Okay, going to jump in, and for a few minutes, we're just going to talk about, what is this linear graph stuff? Like, what do we need to know about the map of this topic? Well, the first is the XY plane that I mentioned. This is what we call the XY plane, or the coordinate plane. The basic things to know, and to understand the rest of the language of this topic, you got to know this stuff pretty well. We've got our x-axis, that's the horizontal. We got our y-axis, that's the vertical. And then every point on this graph has certain coordinates, and we write those coordinates as x, y. So for example, if we were at this point right there, we would do x, y, and that would be 5 is on the x horizontal, and 3 is the vertical. If this is all feeling pretty basic, don't worry, we're going to get through into the questions pretty soon. And if not, then yeah, this is the main stuff you got to learn. What do we actually do here on the XY plane? Well, usually we're dealing with lines, okay? So straight lines is the most common thing we're going to see. So let's draw a straight line, and I'm going to just use one of the point that I started with right there. Okay. So that's a straight line, and I'm going to pick another point on this graph right there, just so we have our beginning and end. The line, by the way, might keep going. In fact, technically every line, keeps going forever, but we'll just deal with the part here on the graph. The chunk of the line that begins and ends is called a line segment. Okay, so this point down here, we would have -5, -3 for those coordinates. And now let's talk about slope. Slope, in just sort of regular language, is the steepness of the line. Okay, that's kind of the definition of slope. How much is it going up as we go from left to right, like you're reading? But how do we actually measure it? You probably remember this: rise over run. At least that's how slope was always taught to me. Rise over run means how much did the line go up versus how much did the line go over to the right. And we're going to see that in a minute, but the key thing that you've got to know about slope is high slope equals steep line. Low slope equals shallow line. By shallow, I mean kind of like flat-ish, right? And negative slope, well, that's going to be a downward line. I don't mean straight down, but like down toward the right. So for example, if I were to sort of color code it in here, a high slope line, a really steep one would be like that. A shallower line would be something like that, not going up that much. And then a downward slope, a negative slope would be anything like that that's headed down as we go from left to right. Okay, let's declutter there. And let's go back to this rise over run. Well, this is how we actually quantify how much is it going up, or down. Let's do rise over run for our little blue line right there. Well, between -5, let's go from -3 to 3 on the y-axis, because that's our rise. We went up by six bumps on the board. Okay. Rise of 6. And we likewise went over from -5 to 5. We went over by 10, or a run of 10. So our rise over run in this case would be 6 over 10, or we could call that 3/5. Okay. 6 up, 10 over. So as this line keeps going forever, it's going to always go up 3 over 5 or up 6 over 10. And it's going to keep doing that all the way to the right, all the way to the left. It's going to have the same slope forever. Well, if we ever needed to calculate the distance between this dot and that dot, that's the next thing we're going to take a look at. The distance between points. Well, you might have noticed, if you've been studying geometry on the GRE, you probably have gotten used to looking for shapes inside of other shapes. And especially a lot of times we're looking for triangles, because triangles are very nice. And we have a triangle right here. This whole blue thing is a triangle. In fact, it's a right triangle, which means we can use the Pythagorean theorem. What is that? It's x squared plus y, excuse me, it's usually written as a squared plus b squared equals c squared. And that c is the hypotenuse of the triangle. So the long side of the triangle is also the line that we're trying to measure the distance of. It's the shortest distance between those 2 points. So in this case, it becomes x squared plus y squared equals basically distance squared. Okay, so we're going to pretend that our line is the hypotenuse of a triangle, and lucky us, if we know the slope, we automatically know the rise, or excuse me, the other 2 legs of that triangle being the rise and the run. There's one last of these basic sort of things I want to touch on before we go on and actually try some of this stuff on some questions. And by the way, as I'm going, if you guys have questions for me, please send them in the chat. I would love to answer them. And one of the things about linear or graphs in general, the reason why I thought it might be a decent topic is more than any other, or than most other math types, there's like a lot of almost vocab that comes with it. Like this is a lot of like quick facts. That means there might be sort of things that are jogging your memory and you're not sure exactly what they go with, etc. So let me know if you have any questions. The last of those quick facts is the line equation for y equals mx plus b. Okay, so the line equation is a form of equation that every straight line can be molded into this form. And to do it, all you have to do is morph it so that you have just y by itself. Effectively, you just solve the equation for y, and what you get on the other side will be mx plus b, aka a coefficient times x plus something else. Why bother? Why bother moving all of our lines into this form? Well, it's because once we get it in this form, there's a couple very powerful things. M, or the thing that's being multiplied times x, is the slope always, once you get it in this form. Oh, it's not the slop. It is the slope. There we go. And then B is something we haven't mentioned quite yet. And that is the y-intercept. The y-intercept is a very helpful thing to know. In this line that I drew, our y-intercept is actually at 0. That was a little hard to see. It's actually at 0, or we typically call this the origin, the 0, 0 point. It's where your line passes the y-axis. So here, our line passed the y-axis at 0. We can imagine if we like moved our line up, you know, if that was our line, our y-intercept would be 5. Every straight line, except for ones that are perfectly vertical, is going to have a y-intercept somewhere. So what this does is it basically tells you the slope right off the bat and that y-intercept right off the bat. And if you have those 2 pieces of information, you can learn a lot about the graph. You can learn whether it's going up or down based on that slope. you can learn whether, it's sort of high up on the plane or lower down on the plane based on that y-intercept. And that's all you need to define everything that you would need to know about that line. So get things in y equals mx plus b form when you can, because it's going to make the line a lot easier to understand, and it's probably going to translate into a way for your brain to sort of visually interpret the line. You kind of understand where the line is, and I think that can help you in solving the question, and even in like avoiding falling into some trap answers. Okay, this is basically the main basics of learning these graphs for just the straight up linear part. And so now we get into the more fun part, which is actually trying some problems. So I'm going to clear all this up. And we're going to look at a few problems now that just test us on these straight lines. All these problems are from our GRE 5-pound book. It has a whole chapter in there about these coordinate problems. So try this one first. We're going to look at 3 right here in a little batch. Try this one first. And chat, everybody, or me in the chat when you have a guess of your answer. All right, we got our first vote in. Take another 30 seconds to a minute. Trying to figure out which of these could possibly be that line based on especially that slope and intercept stuff we just talked about. So I put these little circles on the ones that have votes so far. Tell me in the chat, are there any that you're very confident it can't be? Any of these 5 that you might eliminate more quickly? A few folks are saying D and E as elimination ones. Ami, you said that. Richa, you said that. And I agree with you. I know right off the bat it's not D and E. Tell me in the chat why. Why is there no way it's these? Only one intercept. That's actually a great way of summarizing why both of these are wrong. This line here that we have, that we're analyzing, it crosses the y and the x-axis. So we know that it should have a y-intercept And I didn't mention this yet, but the x-intercept, that's a thing too. Where does it cross the x axis? These are not going to have that. We didn't specifically address this, but what does it mean if you don't have a y and an x? If you only have one or the other, then you're looking at a straight up vertical or straight up horizontal line. For y is 2. Let's go to, I don't really know where 2 is on this one because there's no numbers, but I'll imagine that 2 is like there. Y is 2 is just, you just go to the y of 2 and it's there the whole time. So it's completely flat. And likewise, x is -2. Well, in that case, I'm going to go to where x is -2, maybe like there. And that line is going to be straight up and down. So both of these, they will never impact one of the two intercepts. We need something that hits both, or one of the two axes. We need something that hits both axes. So yeah, those are out. Now let's take a look at A or C, which are the two that actually got votes, I believe. And I'll tell you how I would think about this one. One thing catches my eye right away about this graph is that I have a negative slope. And then I know that I'm probably also going to need to know that I have a positive y-intercept. Okay, I'm crossing the y-axis up here in the positive zone. So when I just look at these three, A, B, C, I can't tell. I can't quite tell what's going to be positive or negative slope or y-intercept. So what do? I move it into y equals mx plus b. So I would take that, and I can see that it'll be, here, I'll type this, that'll be a lot faster. 6y equals 7 minus 6x. And then it's going to be y equals 7/6 minus 6x. Now, remember, I have y equals mx plus b. That's usually how we say it. But y equals b plus mx, that'll happen depending on how you do the algebra. And that's certainly no problem. Both of these are okay. These both work. So here, that's what we have. We have b plus mx, though it's a negative. So this means we have a negative slope. And 7/6, that's a positive y-intercept. So right off the bat, I'm drawn into A since it meets those two qualifications that I needed. I'm just going to check these other two to make sure I didn't mess something up. Oh, nice. Here, all I have to do is divide by 3 everywhere. -4/3 x minus 1 once I divide by 3. So I have a negative slope, negative y-intercept. So that line would be something like this. It'd be like that. Going down, but it's lower down on the graph. And then C, just to confirm, let's see, I got to move that 10 over there. 5y equals -4x plus 10. And then y equals -4/5 x. I hate when typing with fractions is not the most fun math thing to do. -4/5 x plus 2. This time, did I mess something up? I did. I was supposed to subtract that 10 over here since I moved it to the other side. So it's -10 and then -2 over there. So same deal, negative slope, negative y-intercept. It would look pretty similar to this line. So there we go. A was our answer. And we got there by checking for negative slope, checking for positive y-intercept using y equals mx plus b form. Let's take a look at the next one. Next one is here. And the unfortunate thing is they're not always going to show you the graph. Sometimes you have to imagine the graph and what it looks like or draw it out. Try this one. right, we got a couple votes in. Take another minute or so. Okay. Got a few votes in. There's a couple different ways you might think about this one. Did anybody actually draw out a graph? If you did, I'm curious, tell me in the chat if you actually drew out a graph. We got at least one yes. Josh, you said, yeah, you try to. That's great. I think drawing on these graph problems when they don't give us a graph is a great way, like I said before, to just kind of like imagine this line, and actually more than imagine it, like see it, and that'll tell you some key stuff about it. I'm going to start by drawing a graph, and then I will show how we might do it sort of without needing to do that. But for starters, I would just draw my two lines, and then I would say, okay, 4, 9. So I'm going to go just kind of approximating where that might be. The relative location is the important part. So then I'm at 6. So I need to go over to 6. So I'm going to go over a little more than where I was at the 4. And here, let me label our X and Y. You don't always need to do that if you're writing it out for yourself, but it helps us to just remember where our X, Y goes. So we're going to go over a little farther. And I know it's going to be somewhere around there. Why there? Because since I know we have a negative slope, we need to be going down. But the slope is -2. And that's not a super duper steep slope. So I don't think it's going to get all the way down here. Here's what I'm going to do. I'm first going to think about this as if it was rise over run. And I think this is a great way to do it if you're just getting started with this type of problems and you're trying to like calibrate, what does a slope of 2 actually look and feel like? What does a slope of 10 actually look and feel like? -2 would mean the rise. Let's get a nice thin line here to show this. The rise would actually go down 2. So the rise in this case isn't a rise, it's a fall. Down 2 and over 1. So in this case, our rise is actually -2 and our run is 1. If you have just a straight up number, the run is 1. So we went down 2 over 1, and then I picture doing it again, down 2 over 1. And what I can see here is that I went down 2, and then I went down 2 again. So this sort of intermediate point would have been at a height of 7, and that one would have been at a height of 5 since I went down 2 each time. So in this way, I'm almost treating it like little board game hops. And that is our final answer of 5. But let's say you don't feel like drawing all this out every time. You don't feel like rising over running, with your finger on your graph. How are you going to do this? Well, let's take a look at our 0.49. And then 6y. Those are our 2 points. I'm going to go with, Ami, you mentioned this. You said you actually set up an equation, y minus 9 over 6 minus 4. At this point, it's not an equation, but it's a fraction. Okay. What this is, if we sort of, let me label our 6y here. Here we have our first y being subtracted from our second y. And then we have our first x being subtracted from our second x. And this is kind of the mathematical way to think about rise over run. Change in y, change in x is sometimes how you'll see this phrased. And then another way that you'll sometimes see it, and these are all just sort of different ways of explaining the same concepts, is y2 minus y1, x2 minus x1. What that means is, yeah, take the change we got in y, divide it by the change we got in x. And what's that going to equal? Well, this is our rise over run, so that's going to equal our slope. So I didn't show this on the first review, because I always think of rise over run just as a sort of on the graph. But if you want an equation for finding the slope, and sometimes that's something you got to do, this is how you do it. The change in y divided by the change in x between those two coordinates. So if we come back up here and we say, well, if it's equal to our slope, that's got to equal -2. Then this will come down here. And let's do this math. We're going to have y minus 9 divided by 2 equals -2. Pardon my handwriting here, y'all. Y minus 9 equals 4. And then y is going to be 5. Same thing we got by sort of visualizing it on the graph. And that's always good. And something I kind of like about these problems is the visual and the algebra gives you two different ways to sort of check your answer. As a matter of fact, the official GRE book, the official guide, I was just looking at this topic today, and I realized they count this as an algebra topic, not a geometry topic, in their textbook, which was kind of funny to me because I think it's pretty clearly geometrical. But it also has, for sure, algebra in it. You know, y equals mx plus b, solving for that, etc. So we confirmed our answer here, and we are ready to go. Use this slope equation when you need to. Let's look at one more basic. By basic, what I really mean is one more question about linear graphs, and then we'll get into some of the more advanced stuff with our last 20 minutes. Chat me your vote when you got one. We got some votes coming in. Thanks, y'all. Tell me in the chat how you did it. You know, just a sort of one sentence version. What did you do here? And I'll explain when we come back what I mean by this. Beware of choose all. Okay. Any thoughts? What I mean by beware of choose all? Why is this word, this phrase, deserving of this caution sign here? Alarm. Be careful with these. What do you guys think? We'll come back to that. And let me know in the chat if you think of something as we go. Joe, you said because it can encourage you to overthink it. Yeah, I do think that's true. I think the fact that you can pick one, like on this one, you can pick 1 or 2 or 3. It's like, oh, should I keep, should I go back and try this one again? Like you can't fall back on just being confident in one answer. So that's one. And then the other one that I was thinking of is it just takes a long time. It means you have to test every single one. It basically means each one of these is its own question that you have to click yes or no on. As a matter of fact, a third thing is because of that, because you have to correctly do yes or no on all 3 of these to get it right. There's no partial credit. It's just, did you get them all right or did you not? These are statistically a little tougher as well because you have to make several correct choices in a row. Doesn't mean you never do your choose all, but it means, if you're running out of time and you run into these, might be something that you want to be more likely to guess and skip on perhaps. But let's just tackle this one. A few of you said, when I said, how'd you do it? You said, well, you used the y equals mx plus b form that they gave us, and you just plugged in these things. So let's do that. Remember, this is x and y. That's how our coordinates go. And we're just going to plop those into our equation and see what happens. Y equals 2x minus 8 becomes, if y is -2, equals 2 times 3 minus 8. Well, let's see. -2 equals 6 minus 8. -2 equals -2. That's a true statement. And if your algebra leads to a true statement at the bottom, that's one of your correct answers on this. So this is something we haven't explicitly said yet, but you can find out if a point is on a line by seeing if those coordinates make the equation true. Picture, let's draw what this graph might be. It might be something like, if this is our plane, we got a negative slope, a positive slope, negative intercept. So it might be something like this. And what we're doing by plugging in our coordinates is, I almost picture this like we're like locating the line. If we submit this line, it runs it through the line equation. If we submit that point and try to run it through this line equation, it's going to tell us something fake. And we're going to know that's not right. If we submit this point, if we submit that point there, it's going to try the equation and it's going to tell us something true, like -2 equals -2. And that's what we want. -8, 0. Now this is a sneaky one. I think I got a couple of you with this one, or whoever wrote this problem got you with this one. Because look what happens when we plug it in. Do some arrows here to keep our work neat. When we plug this in, y equals, our y is 0. 0 equals 2 times -8 minus 8. 0 equals -16 minus 8. 0 equals -24. That can't be right. Nope. But why did multiple people think B might be it? Because if you swapped them, if we had 0, -8, you can try that one, and that one would be correct. because -8 is our intercept, right? -8 is our y-intercept. So, you know, that tells us that 0 on the x, -8 on the y, it's going to be on the line. So careful about x comes first, y comes second. I myself get those mixed up still to this day. To be honest, if I'm going to get one of these problems wrong, it's usually because I swapped my x and my y and my coordinates. So check your work is a good way to practice that, especially if you are making that mistake often. Just be careful. Let's check the last one. And this time we're going to do y is -7 equals 2 times 1/2 minus 8. Well, is it true that -7 equals 1 minus 8? Yes, it is. That is a true statement. So our answer here is A and C. Not B, but B was a trap. Okay. We have almost 20 minutes left, and I'm going to take us through a couple of the just more advanced ways that they might test the graph system on the test, and we're going to look at a couple of questions based on that. Not just lines anymore. We're going to look at inequalities, parabolas, and shapes. Inequalities is in some ways the most straightforward of these. Imagine that instead of y equals mx plus b, becomes y is less than mx plus b. Well, let's say this was our line here. As a matter of fact, this perfectly diagonal line with a slope of 1, you can see them going up 1 over 1, up 1 over 1, going through the origin. That line is in fact y equals x. Well, if they change it to y is less than x, you're actually going to have the same border line show up on the screen. So you can still kind of treat y equals mx plus b the same way. It's just that now, let's see how I can zoomify this. Now everything down here is going to be like shaded in, because this is everything that's under the line. Oh, beautiful. This would be y is less than x. They're going to still have the same line, and then they're going to, like, probably in dark gray, shade in everything beneath it. So if you ever see that, that's what that means. And if you ever see the reverse, y is greater than x, then will this work? Whoa, I was hoping that might happen. Then yeah, it's going to just totally flip. And you're going to wind up with everything above the line is shaded, because that's what everything is that matches the statement y is greater than x. Here, y is 4, but x is 2. So just going to note that here on the screen. A less than sign means shaded below the line, and a greater than means shaded above the line, indicating that all of this stuff satisfies the inequality, and the line itself is the border. Now let's get into the trickier one, which is parabolas. Parabolas are those old U-shapes. Those old U-shaped graphs, you know, something like this. Anyway, it tends to kind of look like that. Now, parabolas happen for a specific reason. They happen when you have x squared. So in fact, this one I just drew is the parabola approximately for y equals x squared. Don't believe me? What if we plug in 1 as x? We're going to get 1 as y. If we plug in 2 as x, we're going to get 4 as y, approximately. My drawing's not perfect. And so on and so on. 3 would give us 9, etc. So that's why this graph gets really high really quickly. And it does the same thing on the other side, because -1 squared is 1, -3 squared is still 9, and so on. Well, that is one thing, y equals x squared. But what if our parabola moved? What if our parabola moved up there? Same shape, but now it's just like higher up. Does anyone know? Tell me in the chat, what is the equation for this? What is the equation for this parabola? If you don't know, you can guess. How might we change this? Yeah, Josh, you got it. Ami, you got it. X squared plus 2. You both put question marks like you weren't confident, but you were totally correct. This new one is x squared plus 2. Okay, so I'm going to just put some quick notes over here. So y equals x squared is like your classic parabola. Okay, classic flavor. To move the parabola up and down, add or subtract at the end. So just plop on +2 at the end of the entire equation. If I moved it down here, whoop, it would be -2. Right? Change that plus to a minus. This kind of makes sense, right? I bet that's why y'all submitted it with a question mark. You're like, this seems like it's what it should be. It's because we just literally took the result and added 2. That's the same thing that this math is doing. But what happens if instead of moving it up, we moved it to the left? Do y'all know what this graph is? It's not x squared plus 2 anymore. Chat me, what do you think this one is? Josh, that's a good guess. You're like, you're saying y minus 2 equals x squared. Let me do some scratch work over here. Y minus 2 equals x squared, but that's not going to be it, because look what happens if we just move the 2 to the other side. We would get the same thing as before, right? And we know that adding at the end, that's just going to move it up. So this part is less intuitive than moving it up and down. The best way that I can think of to sort of write this out is to move the parabola left and right, add or subtract within what is squared. What do I mean by that? This one is actually y equals x plus 2 squared. X plus 2 squared. So you take the amount you want to change it. We wanted to move it to the left by 2, and you put it inside of the squared term. Now it feels a little counterintuitive, right? I moved to the left, but I added 2. Well, trust me on this. Just try it out for a second. Try plugging in -2 for x. What's going to happen? If I plug in -2 for x, well, suddenly this is going to act like 0, and I'm going to get 0 for y. If I plug in 0 for x, then suddenly this is going to act like 2, and I'm going to get 4 for y. And you can see that's pretty much what I'm getting over here. My -2 point is at 0, and again, my drawing's not perfect, but my 0 point is at around 4. You know what, let's cheat. Let's make it look like I'm amazing. Yeah, there we go. It's at exactly 4. So that's the caveat here of to move the parabola left and right, add or subtract within what is squared. But plus moves left, minus moves right. Kind of weird. Memorizing this can be annoying. So what I would do if you happen to run into one of these is, just make sure you try it out. Try it out on your paper by plugging in points like I just did to make sure that you moved it in the right way. There's actually, speaking of formula-ish stuff, there is a y equals mx plus b, but for parabolas. Let's go back to classic parabola. Something I like about teaching this way is I don't have to worry about what I erase because you can just go watch it on YouTube later. What the line equation for the parabola is, or the equation for a parabola is, y equals a x minus h squared plus k. So I wouldn't really encourage y'all to memorize this because I think there's just other more important things. But let's say you are trying to ace geometry, you think it's like your strength. Let's say you like these problems and you just want to study them, or let's say this really helps you. This formula defines parabolas, and actually h and k. They mean something. They are the coordinates of the vertex, right? Remember when we added 2 at the end, it meant that we started at a y of 2. When we subtracted, or rather when we added 2, which would make h itself a -2 in there, we started at an x of -2. So if you ever see this sort of subtracting and adding going on with a parabola, h being what's inside the parentheses and k being what's tacked on at the end, those are your coordinates of your vertex. Right there, the bottom point. Just to call out one thing, what is this? What is A? A does not come up much on the GRE. It's just possibly a multiplier. So imagine, if we had y equals 8x squared. Well, in that case, A is 8. That would make it just go up even faster. It would become like, very accelerated parabola. It would make it really thin. And imagine it was the opposite. Imagine it was like 1/8 x squared. Well, that's going to mean everything we pop out is getting multiplied by an 1/8 after that. So it's going to make it get larger at a much slower rate. It's going to become a very wide parabola like that. So that's the main thing I would remember about A, y'all. I have not seen this hardly ever on the GRE, but if it does come up, just know a coefficient, if it's a big number, is going to make the parabola thinner and get tall faster, and a fraction is going to make it wider. Okay, so the last thing that I mentioned is sometimes you're going to see shapes on graphs. Well, what am I talking about? I'm talking about, sometimes they might do something like this. Let's make a circle. Let's move that circle like there. It looks like in this case, my circle has a radius of about 2.5 based on the graph. This is just to give you a heads up that they might sometimes, have a problem that's like a circle on the coordinate plane has a radius of 2.5 and a center at 0, 0. That's the type of question they might ask, planting a shape on the graph. And then they might ask you to find some of the coordinates. So in this particular one, if they asked you, like, what's the coordinate there? You could say 0 for x, 2.5 for y, knowing that the radius of 2.5 has got to be the distance from 0 up to that point. Okay, we don't have much time to actually do problems testing these out, but I want to do at least one. And I'm going to do one of those parabola things, just because that is something we just talked about for a bit. I want to give you a chance to practice. Similar vibe as that first one we did a while back. Which of these could be the equation of the parabola? Give it a go. Chat me your vote. All right. I actually do want to show y'all one more quick one after this. Promise it'll be quick. We won't go over too much. So I'm going to jump in and talk about how we might apply what we just did here. Thanks for the votes, Amiricha, Joe. The first one I would eliminate here would be A, because I can see that it has moved to the left, and I can tell that, okay, this is only moving it up and down. So that's out. And then I'm going to look at, okay, I know I moved it up. So C and D are out, because if I subtract 3 from my final result, that's going to move everything down into the bottom quadrants down here. So now the question is B or E. And this is where that sort of inverted thing comes in. Remember that a minus would actually be over on the right. That would be that. And our actual one here is a plus. How would you remember that? Well, first off, if you didn't, you could always try some coordinates. Like you could say, okay, I want to see, what do I get if I'm at like negative, if I try -3 for x, x equals -3. If I go here, I'm going to get y equals 0 plus 3. So I got 3. If I go here, I got y equals -3 minus 3. So -6 squared plus 3. That'd be -36 plus 3, -33. And I can see that I don't have any negatives for y. Did I do that right? X is -3 minus 3 squared. Oh, of course I did not do that right, because you can't square something and get a -36. You would have 39. You would have 39. And comparing 39 to 3, that is tricky, because I don't have any numbers up here. It's not to scale, but I trust a little more that this is going to, I want to take the lower number here, because I can tell that in the lower section, like it should be, around this negative area, it should be actually towards the lower end of the graph. So that could be like a tiebreaker for y, or excuse me, for E. And remember that HK is our vertex. But that the equation is y equals the A that we don't see very often, x minus h plus k. I hate that h and k look so similar, not so good for this handwriting. And because of that minus, we get the sort of inversion there, where the h in the coordinate is actually the opposite sign of the one that it looks like in the problem. So E is our answer. Nice job, y'all, tonight. The last one that I was going to do, I'm going to show it up here, but since it is 9 o'clock Eastern and we started at 8, I won't have all of y'all do it. We'll call it a night. But here is that problem. I just wanted to show an example of one of those shape ones I was talking about. In this case, it's not a triangle, but a circle. Excuse me, the opposite of what I said. It's not a circle, but a triangle. And they give us the vertices and they ask us for the area. And just like any other geometry problem, I immediately think, what's the area of that thing again? Oh, it's 1/2 base times height. And then I think, okay, I better draw this thing and figure out what the base and height might be. So imagine that there is our plane in bright blue this time. And I try to say, okay, -2, 4 would be something like this. 2, 4 would be something like there. I know it's got to be the same height. And then -6, 6. Whoa, this is a weird looking triangle. It's all stretched out like that. But lucky for me, I can call this the base. And I know that distance because I had to go from -2 to 2. And I can call this the height. Where is the height on this one? It's way over there. Sometimes the height is outside the triangle, but it's always a distance, a perpendicular distance from your base to the very top of the triangle. And that's where the coordinate plane aspect of this question really comes in, because if I had this shape without the coordinate plane, I might not know that height. But since I know that this is -2, 4, and I know that this is -6, 6, I know that this has got to be 2, a vertical distance of 2. So I would have 1/2 times my base was that 4 times my height was that 2. And it would be 1/2 times 4 times 2, or just 4. So 4 would be our area. So good example there of how like the principles of coordinate plane, including that like we had our height built in because X and Y are always perpendicular. Those principles helped us solve this problem, even though it wasn't exactly like Y equals MX plus B and all that. All right, thanks everybody. That's all for tonight. I'll stick around if any of you have any questions you want to ask in the chat. I'm Logan. I hope this has been helpful. Like I mentioned in the beginning, this is not like the most common topic you're going to see on the GRE, but it is one that a little bit of review, familiarizing yourself with these terms that you don't use that often in your daily life can go a long way in like getting you ready for test day. So go practice it if you felt like you were just on the cusp of getting a lot of these right. You just have to sort of shake the rust off. All right. Thanks, everybody.